This is Solve It for Kids.
Hello, my amazing and curious friends. My name is Jennifer, the Dean of all things STEM and STEAM, and this is Solve It for Kids, the podcast that gives kids and families a peek inside the real world of scientists, engineers, and experts as they solve problems in their jobs using creativity, cooperation, and critical thinking. And now please welcome to the show my podcast partner, Galactic Space Geek, Jeff Gagne.
Hello, Jennifer, and hello, listeners. We have got a fascinating conversation ready today with a guest that is talking about something that is happening around the world right now, and we're sure you have heard about it.
Oh, yes, I am so excited for this one. What problem are we solving today?
What is an atmospheric river?
What is an atmospheric river? Yes, this is what I have been wondering because people have been talking about it all over the place. So
Yes.
Clue is our guest today that's going to explain this to us, Jeff.
Today, our expert on atmospheric rivers is Dr. Kristine Harper. She is Professor of History and Philosophy of Science at the University of Copenhagen.
Welcome to the show, Dr. Kristine.
Hi, glad to be here.
Well, we are thrilled to have you, and this is going to be such a great conversation. But I like to start with, so you're interested in all things weather and meteorology. Were you a kid that watched weather and kind of tracked the clouds and all that kind of stuff?
Of course.
Yay!
Okay.
We had a barometer and a thermometer that hung in our hallway. And every morning I got up and tapped the barometer and reset it so that I could tell by the end of the day whether the pressure had gone up or gone down.
Oh,
because if
my
the
gosh.
pressure had gone down, I knew that the weather was going to be worse by the next day.
How old were you when you started doing that?
Well, I had to have been tall enough to reach the barometer. And I was not a very tall kid. So probably about 8. I was probably about 8 when I was tall enough to tap the barometer.
That's fantastic.
And did one of your parents have an interest in the weather that got you to understand what the barometer was in your house?
Well, I did because my dad worked for the California State Division of Forestry, as it was known in those days. And so the weather was really important for him, particularly during fire season.
Oh, yeah.
Because if it were dry for an extensive period of time, that made it more dangerous out in the forest, right?
Oh, yeah.
So he was very much tuned in to the weather patterns because he needed to keep track of what the conditions were going to be for fires. And of course, the more rain there was, the happier he was about that in the summer, because that meant fires wouldn't be as out of control. So yeah, that was just part of what we did. He was also a hiker and liked to canoe and do all those kinds of outdoorsy sorts of things. And if you're doing outdoorsy things, you need to know what the weather is.
Oh, absolutely. Absolutely. We watch for moisture levels here in Florida too. This year we're getting lots of rain, but we have had years where we've been so dry that it's been, lots of fires. How did you go from 8 to kind of being where you are now in a short version, right? Did you study meteorology in college and stuff?
Yeah, so I didn't study meteorology in college. I studied mathematics in college.
Oh, okay.
Okay, so I studied mathematics in college. And then when I graduated, I became a naval officer. And the U.S. Navy
Go Navy
sent me to Spain, where I worked at the Navy's Weather Center in Rota, Spain. And I was responsible for all the big computer center that we had. And these were the days when computers were huge.
I remember.
And they had their very own big rooms that were pumped full of air conditioning. Which was cool. And we wrote our programs on punch cards and we put them in a big card reader. So this was way long time ago. And so I learned about the weather because I was working with weather folks. And the Navy continued to send me to meteorology centers where I was managing all the computers. And eventually they sent me to the Naval Postgraduate School so I could get my master's degree in meteorology and oceanography. So
That's cool.
that's what I did. So I spent 21 years living all over the world doing meteorology and oceanography. And then I taught those things while I was on active duty and also after I retired before going back and getting my PhD in the history of science. So now I focus on the history. My research is now more on the history of the topic, but I keep my hand in on the weather part too, because it's just cool.
It really
It's very
is
cool. Yeah.
And thank you for bringing us all the way up to your PhD, because I really wanted to ask that question. Your PhD, when I did some research about you, interested me so much because it's the history of science. Can you explain to us just a little bit on how your interest shifted from science now and continuing like future research to how you linked it to what got you interested in the history of the sciences that you were so interested in?
Well, what happened is after I retired, I was going to become a secondary math and science teacher.
Mm-hmm.
Okay.
So I had to go back to school to get my teaching credential.
Right.
And while I was doing that in my first quarter back in school, I was taking a class in hydrology. All right.
Ah.
And I explained to the instructor that I was a meteorologist, and it looked to me like a lot of this hydrology was like meteorology only under the ground, right? We were talking about flowing water and all of these kinds of pressures.
Right.
And he said, "Oh, you're a meteorologist." He said, "I need to keep that in mind." And a few weeks later, the head of the science department at the school where I was waiting for me outside of the door where I was attending a biology class.
Okay.
And she said, "We need to talk." And I'm thinking, I don't even know who you are. And I said, "Certainly I can talk. I don't have class right now." And so she said, "We understand you're a meteorologist." And I said, "Yes, I am a meteorologist." She said, "Can you teach meteorology for us starting in January?"
Oh,
wow.
Which was 4 weeks away.
Oh,
I said, "Well, yeah, I can do that. I mean, I've done it before, like how hard could it be?" So essentially while I was going to school full time, I was also teaching meteorology to 70 students, right?
Wow.
And over time, each term, they would ask me to teach something else and meteorology.
No kidding.
And so then it was like, well, do you think you could teach physics? Do you think you could teach earth science?
Oh, my goodness.
Do you think?
You became the science department.
So the thing is that my students, when I was asked to teach, the meteorology course was an upper division course for juniors and seniors.
Okay.
But the courses I was teaching in earth science and physics and astronomy, they were for freshman students who weren't going to be science majors.
Right.
Okay.
Right.
And most of them were going to be teachers. They were going to be elementary school teachers.
Yeah.
Right.
They wanted to be science specialists because there was a shortage of science specialist elementary school teachers in my state. And they were terrified of science.
Yes. I've run into that a lot. Yes.
They were terrified. Numbers were not their friends, and science terrified them. So it was like looking at 70 deer in the headlights stacked up in stadium seating in this room.
Wow.
And I thought, oh, this is not good. How am I going to reach these kids? I mean, they were just terrified.
Right.
So I had done teaching in the past, but I'd always taught people who were specialists in the field. And now I've got people who are not only specialists, but they're afraid to be in the room, but they really want to learn it.
Right.
And I thought, what can I do to calm everybody down? So I thought, what if I told them stories about the science first?
Oh, good.
Nice.
To let them know that people didn't just figure this out off the top of their heads. That it took a long time to figure it out.
Exactly.
So they didn't have to figure it out in 30 seconds.
No.
Because it had taken all of these big name guys decades to figure things
Yes.
out.
Right.
Yes.
And so it was okay if it didn't take them, if it took them more than 30 seconds to figure it out, right? This really,
Yes.
it was
Sure.
not a problem. We could work on it together. I knew nothing about the history of science. I mean, nothing. It had never been
Yes.
brought up when I was in graduate school. We would ask questions. Why are these waves called Rossby waves? That's not
Okay.
important to what we're doing here, right? Why is this called Rayleigh scattering? This thing about the blue sky, Rayleigh, who's Rayleigh?
Yes.
We're not going to worry about that. So I very quickly had to come up to speed on the history of these topics. I mean,
Wow.
literally, I was
Right.
grabbing books out of the library and I was only about 10 minutes ahead of the students at any given time because I was trying to
Right.
figure this out. And it worked. People calmed down.
Yes.
And then they
Yes.
could listen because they weren't terrified. It was
Yes.
like, oh,
Yes.
there's a narrative. There's a story here.
Yes.
I said, oh, there are
Yeah.
lots of good stories here. It's just like full of cool stories.
Yes.
I like it.
So time passes. And one day I'm down in my office, which was in the basement. And my department head, who was a chemist, plops herself down in my office and says, we need you to get a PhD and we need you to do it now.
Oh my gosh. You are the go-to woman at this school, right?
And I said, a PhD in what? And she said, I don't care. Just go do. And as it turned out, the university 15 miles to the south had one of the few history of science programs in the country. And I basically
Nice.
talked my
That's
way
fantastic.
in to
Yeah.
this program. I did all of my coursework in 1 year. I'm not recommending
Wow.
this to anybody. I mean, I was about ready to keel over by the end of the year. I
Yes.
got
I
all
bet.
my coursework done in a year. And then I got my research done in another 3 years
Wow.
because I was like, knew what I wanted to do and was really
right.
kind of motivated. So that was what happened. So they were holding a job for me because the idea was that I was
Right.
going to come back,
Exactly. Yeah.
and then they were going to turn me into a tenure track assistant professor. Okay,
Right.
that's fine. Except then I got the word, you'll never be able to teach that history of science class you want to teach because we need you to teach physics and all the labs all the time, plus teaching meteorology and oceanography and earth
Oh my
science and,
God.
My goodness.
like partridges and pear trees, right? I mean, like it was going to be the whole kit and
Right.
caboodle. And I thought, I did that before I got the PhD.
Right.
And so, like, I don't think so. And they were
Yes.
really upset with me. But I spent that year, my first year, writing books for middle schoolers. I wrote 6 reference books for middle schoolers that year. And then the next year I got a postdoc, and then I was hired on as a tenure track assistant professor at a New Mexico Institute of Mining and Technology. And so that's what I did. And I was there for a couple of years. And then an opportunity came for me to go to Florida State University, where I helped science and math majors who were going to be secondary science and math
Yes.
teachers
That's fantastic.
work on their teaching credentials. And so my job was to present the history and philosophy of science and mathematics to them so that they could incorporate that into their classrooms.
Right.
Because like I said to them, you all are keen on science and math.
Yes.
But I said, not everybody is. And you need
No.
another way to reach those folks. That's how I made that transition.
That's an incredible story. And that kind of shows that we in the science field are aware that not everybody likes science. And like you, I'm an author. And so I've run into this with teachers who are not, afraid, or, the one thing that I run into is they feel like they have to know all the answers. And I'm like, nobody knows all the answers. It's fine. I mean, I've taught science. It's fine to say, I don't know. Let's go look this up kind of thing. So, but now we're going to get to the big question, because since you've laid us all out with all of your teaching, we're hoping you're going to help us understand a topic and a question that has been in the news within the last year. What is an atmospheric river? I mean, I've been around a long time now. I'm not into meteorology, but I have never heard this term before. So if you have to explain this to someone, what do you say?
Yeah, atmospheric rivers are so cool. And
I will agree with that.
the atmospheric river that generally hits the U.S. West Coast is often called the Pineapple Express.
Oh,
And the term alone used to just crack me up when I was living in Oregon. I thought, what a name, the Pineapple
I've never heard that.
Yeah. How do you not want to know more about the Pineapple
Right.
Express?
Not want to know more about something called the Pineapple Express. And since I spent 3.5 years in Hawaii when I was on active duty doing weather forecasting in the Pacific,
nice.
it was like, oh, I've been where they grow pineapples. You know, they were growing less than a half a mile from where I lived. So what happens is we all know how regular rivers are. You have a regular river, you got water, it's got banks on two sides.
Mm-hmm.
If it's small, we call it a stream. If it's really small, we call it a creek. Yeah,
or a crick, depending on where you're from.
Or a crick, depending on what kind of part of the country you're from.
That's what we did when I was a kid. It was the crick.
Yeah, that's right. And then some rivers are big, and then some rivers are even bigger. So for your listeners who live near the Mississippi River or the Missouri River or the Susquehanna River, right? Those really big rivers, you know, they have really big bridges that go across them. And for many years, only had ferries that went back and forth across them. And that's how you got back and forth, was on a ferry.
Right.
So you're looking at something that's pretty big. And if you get too much rain, it comes out of the banks.
Yes.
And it gets even bigger, and then you have floods, right?
Yes.
And so even today, there's lots of flooding going on in upstate New York and in Vermont.
Oh, yes.
Because there's too much water. There's too much water coming down all at the same time, and there's no place for it to go, right? So it kind of hops out of places. But when it's being well behaved, it stays in the bank. And it flows from the mountains down, and then it finally ends up in the ocean someplace. Okay.
Right.
All right. But with an atmospheric river, the atmospheric river is up in the atmosphere, and it's not water like in a river, which is like liquid that you can get out of a faucet and pour through your hands or load up into a balloon and lob at one of your friends during the summer. Okay. Not that kind of water. Okay. The kind of water that's in an atmospheric river is like fog. So if you've ever been outside on a really, really foggy day, so foggy that you can't see very far, or you've ever been in an airplane and you've looked out and you're thinking, where are the wings? I don't see them anymore.
Yes.
Okay, so that's water vapor. And it's water vapor like that that forms the atmospheric rivers. And the atmospheric rivers are much, much bigger than a regular river.
Oh, wow.
Much, much bigger. So I want you all to be thinking, what's the biggest river you've ever seen? You know, like think about the biggest river you've ever seen. And now this atmospheric river is probably 200 to 300 times bigger across than that river that you know about. All right. So it can be up to 350 miles across and up to 1,000 miles long.
Whoa.
So 1,000 miles is the distance between New York City and Minneapolis.
Oh my gosh.
It's this distance basically from the California border with Mexico to Oregon. That's also about 1,000 miles.
Wow.
So there is a lot of moisture packed in there, and it may not seem like a lot because, you know, you can just kind of wave your hands in it.
Right.
And it, you know, it doesn't seem like there's
just
all that
fog.
much moisture there. But for anybody who's ever been in a really foggy place and out for very long playing, you notice how your clothes get damp.
Yes.
Sure.
And it's like you can't get dry.
Yeah.
That's because there really is quite a bit of moisture up there. And the thing is, it condenses. Ultimately, it condenses when it cools. Okay, so where does this moisture come from that's up there? You know, like where does it come from?
Yeah.
Okay, so it's starting down there in Hawaii, basically. And it's evaporating from the ocean. And so when the sun's hot, it evaporates that water. and it rises and it
Right.
condenses and it forms all these clouds. That's how
Okay.
clouds form.
Yep.
Okay.
And then this huge, massive band, very wide and very long, starts heading with the wind towards the west coast of the United States.
Is this the Pineapple Express? Because it
This
comes
is
from
the
Hawaii?
Pineapple Express.
Ah,
And it
okay.
brings all this warm, moist air towards the coast. Now, it can end
Wow.
up in Southern California. It can end up in Northern California. It can end up in
Ah.
Oregon. It can end up in Washington. And it can end up in Canada, right? It can end
Right.
up
Okay.
anywhere along the West Coast. It just depends on where the wind is blowing. And in this case,
Right.
we're talking about the jet stream, right? We're talking
Right.
about where the movement is, and it's taking this big, massive moisture with it. And then once it hits the mountains, then it lifts those clouds up, and
Oh.
the moisture condenses to form droplets, and then they all fall out. And so that's why you
Oh.
can end up with like 5 inches of rain falling in a fairly short period of time, because it's as it comes in uplifted,
Oh.
Right.
it can't hold all those droplets get together. It takes 1 million of those little water vapor droplets to make one drop to fall out. And then once
I
they
didn't know
start
that.
falling out, they start catching other things, and then they all come out. If it's high in the mountains, it comes as snow. If it's down at
Ah.
lower elevations, it comes as rain.
Right.
Okay.
If you're in the Pacific Northwest and one of these comes in the winter, the temperature rises. The temperature actually
okay.
increases because it's warm air coming
Right,
from Hawaii.
right,
When it
okay.
can be kind of
Right.
cold in Oregon and Washington in the winter, right? And so you may be thinking, well, that sounds good, like if you were to read
Yeah, it's not
right?
cold.
Okay, but if it comes in and it falls as rain on big snowpack already in the mountains, and then that snow starts to melt along with the rain, now you've got huge amounts of water that are running off of the mountains
Oh.
into the rivers,
Uh-huh.
along with all of the rain that's already falling into the rivers and coming in from lower elevations. And then there's no place for the water to go except outside of its banks.
Oh,
And then there's a
okay.
big problem. So
Right.
this past year, we had one after another of these. In fact, I looked it up because I didn't know the answer. 31 separate atmospheric rivers hit California between
gosh.
October of 2022 and March of 2023 this year.
Whoa.
Wow.
31 of them.
Wow. So, with you also being a specialist in the history of science, the news and TV really catches on to trends. So, atmospheric
Yeah.
river, and people love to say, the newest buzzword. So, everybody's talking
Yeah.
about it right now.
Yes.
Yeah.
This can't be a new thing. How long has this been happening from long before it was called the Pineapple Express?
Well, my guess is, of course, it's probably always happened.
Right.
Right.
But it wasn't as strong or as severe as it is now, and it wasn't
Okay.
as regular as it is now, right?
Okay.
Because with a warming atmosphere, we have more water that's evaporating,
Yes.
Right.
right? Okay,
Yes.
so it can hold more. The water's warm, right? And we all know that as the water gets warmer, the molecules move faster, right?
Yes.
Anytime something warms
Exactly.
up, the molecules move faster, right? And so you've got this water in the ocean and it's warmer too. And then you're evaporating that water. And
Right.
because of the heat rising all over the globe, we have this change in weather patterns, and we have change in jet stream patterns. And so
Yes.
we're seeing a number of overall atmospheric circulation patterns change as well.
Wow.
And so it's not that this didn't happen. I mean, when I was a kid growing up in Northern California, every once in a while, we'd totally get slammed by something that would come in off the ocean.
Right.
Right.
And let me tell you, satellites weren't so good in the 1960s when I was a kid.
No, they were not.
They were not so good. I mean, everybody thinks now, well, all I have to do is get online and I can see the satellite picture loop, right?
Yes.
And there it is. I can see what's going on. When I was a kid, maybe there was one satellite picture a day.
Yes.
And it wasn't very good. It was really kind of a sad picture. Okay. Like it was better than nothing, but it was really a fuzzy photo.
Right.
And maybe the angle wasn't really good. And actually it was a mosaic. And so they'd had to cut it in pieces and then glue it back together again.
Yes. And
you know what? There aren't people sitting on little rafts in the Pacific saying, there's a storm coming your way.
That just hit me. It's super funny.
Yeah. Well, okay. So I think the thing most of us have heard about is how it affects us. So these atmospheric rivers, from what I was hearing, were planes can't fly in them or something. Like, at what atmosphere do these occur? Are they occurring where planes fly? Is it above? Is it below? Like, that's kind of how I heard about it.
Yeah. Okay. Well, so the jet stream is where planes fly.
Right.
Right. So 33,000 feet.
Yes.
More or less. Now, these aren't at 33,000 feet.
Okay.
Okay. This is at a lower level, but the jet stream is still what steers it.
Oh, okay. I got it.
There. Okay.
Okay.
But that energy still influences the atmosphere, because the clouds at 33,000 feet, those are like the little cirrus clouds. That's just ice crystals up there.
Yes. Okay.
Yeah. You know, that's why we can see jet contrails, right?
Yes.
Because the moisture is released and then, it makes the little cloud that's up there. And then if it's really dry, it just kind of goes poof and then you don't see it anymore.
Yes.
That's just ice crystal-y stuff up there. So this is lower level. This is significantly lower level kind of clouds that we're looking at, but they're massive.
So the planes have to go up through this, is what they're saying, which is why it was affecting some of them flying, or the rain or whatever. All of that.
Well, if you're in San Francisco and one of these is bearing down and you're trying to get out of the San Francisco airport, then yes, you are flying up through it to get out to clear skies.
Yeah.
And
assuming it's safe to do that.
Assuming you can see. I mean, like I used to do forecasts for pilots. You have to be able to see to leave, right? I mean,
kind of.
Like,
it's kind of important.
Kind of important. Yeah. Kind of important to be able to see before you take off. So in places like San Francisco, where the runway literally stops at the water. I mean, I don't know how many times she's flown into San Francisco, but when you're landing in San Francisco, you're coming in right over the water in the bay. And so, yeah. And in Boston, it's the same thing. You're coming in, except
that one I knew. Yeah.
Express in Boston, right? They're doing nor'easters in Boston. But if you've got extensive rain and the visibility is what we call below minimums,
right?
Then nobody's going anywhere because it's not safe.
Okay.
It's not safe. Yeah, it's not safe.
Sense.
So, is it a bumpy ride in and out of there? I mean, let's say you can take off. Well, yes, it is.
Hang on.
But you're not flying in that stuff for very long, right?
Yeah.
So, I mean, if you've got good visibility, well, it won't be really good if it's raining that hard. But if you've got good enough visibility, so it's safe to take off, then you take off and then you just
go
fly
up over it. Okay.
Over and then, after a fairly short period of time, you're up and over it. And it's like, bye-bye. And then you're off, flying east. But if you were flying, say, from San Francisco to Seattle, while one of these
you're in it the whole time. Yeah.
You're going to have to go in and above, and then you'll be able to see basically the whole thing going on below you, as you fly further north. It won't be the whole way because it's not that wide, but so it's actually really cool to be in a plane when it's stormy underneath you, as long as you don't mind a little bit of a wild ride while you're taking off.
Yes.
And then potentially landing, like you were saying, depending on where you're going, if you're not getting around it.
Yeah, landing is trickier because if you can't land, then you have to go someplace else.
Someplace else, yes.
Yeah, you have to go someplace. You have to go someplace where you can land, and it may not be where you planned on going.
Yes.
So
That's right.
you've already given us a ton of homework. I'm going to be learning a whole lot more
Right?
about these.
Me too.
This is super fun. I do want to ask, I want to go back to something you mentioned before. You said you wrote a handful of books about
Yes.
science for middle schoolers. A, can you tell us a little bit about those? And B, I want to know, were atmospheric rivers any part of any of those books?
Yeah.
No, atmospheric rivers weren't part of any of those
Okay.
books. Yeah, I wrote a book about the Mount St. Helens eruption,
Oh, I remember
okay.
that. Yep.
how that impacted life. And I
Right.
wrote a book about Hurricane Andrew.
Okay.
Also remember that one. Yes.
Yeah, okay. And then I wrote a set of 4 reference books for Facts on File, which
Oh,
was
yeah.
about the earth
Okay.
sciences. So it was, about people who were involved and, kind of the timeline of when thing happens and what kinds of questions were important
Yes.
in
Right.
earth sciences, that
Yes.
kind of thing. Yeah.
Okay.
And then later that year, I signed on and wrote a book that's more for high schoolers and lower level college students
Right.
about a history of meteorology in the 20th century,
Okay.
which goes decade by decade and talks about what was going on and what people were discovering and that
Right.
kind of thing. Atmospheric rivers did not figure in there. I'm sorry.
They may not have figured into the ones you wrote then, but I can imagine with how much it's affecting the West
Yeah.
Coast of America right now, I can imagine it's going to make it into a lot of books that are
Right.
being written now and about this time,
Yeah.
because we're talking about atmospheric rivers. And the first thing that my brain can come up with is, turns out I live in Colorado. I've never actually lived in California, but I never hear about El Nino or La Nina anymore. But now we're talking all about these atmospheric rivers, which seem to be, a similar weather and atmospheric issue that's bringing very different weather. And
Yes.
as you were talking about, the temperature's hotter, so there's more moisture. It's becoming sort of more extreme. I guess extreme weather is also a term people like to use.
Yes.
And like you mentioned, 31 of them in just that 6-month span of time in 22 to now. That's a lot.
Yes. Absolutely.
That is a lot. And of course, California needed that water.
Yes.
Yes.
It desperately needed that water. It did not need that water all at one time.
Yes.
Yes.
Yes. I mean, that's true.
It did not. And of course, this is now an El Nino year, which will impact the West Coast. I mean, I was in graduate school of meteorology in 1982, which was an El Nino year, and hillsides were sliding south of Monterey, where I was. And so it tends to accentuate. El Nino years tend to accentuate the amount of rainfall in California to begin with. So it'll be interesting to see what happens this winter if the El Nino situation accentuates the presence of atmospheric rivers, or whether it just accentuates the normal kind of rainfall that they get because the pattern changes. But I'll be interested to see what this year's weather pattern looks like in California.
We'll be watching.
Yeah. Well, this has been so awesome. I'm very curious because, we ask all of our experts to give our listeners a challenge. What challenge do you have for our listeners, Dr. Kristine?
Well, okay, listeners, I'm sure you all live near some kind of river or creek in your area. So what I'd like you to do is see if you can figure out how wide your local river or stream is. How far it is from one bank to the other.
Okay.
I want you to figure that out. And then I want you to divide that into the width of an atmospheric river. And we're going to call that at about 350 miles. And figure out how many times wider an atmospheric river is than the river in your hometown.
I like it. I like it. I think we're going to get some wide-eyed listeners after they do the math on this.
Yeah. So I grew up with a creek, or as we called it, a crick in my backyard. So, and I actually recently visited there this past year, and because I spent when I was a kid, my whole childhood down there. And so now I'm going to go back and like find my photos because, we lived there once and it got huge. Like it turned into a river. Like we had that much rain coming down and it turned into a river in our backyard. And I will never forget that. It was incredible. My parents weren't thrilled, but I thought it was the coolest thing ever. But I'm excited to see if kids do this. Well, this has been a truly amazing conversation. I've learned so much. Thank you for being on Solve for Kids, Dr. Kristine.
Thank you, Dr. Kristine.
It was great fun. Thanks for asking me.
That's the conversation we all needed so we can better understand atmospheric rivers and how they are affecting our planet, not just California. And the challenge, Jen, find the width of your local river or creek, divide it into 350, which is the average width of an atmospheric river. There are so many different ways you can take this, whether it's finding the width of a local river or creek or water source, or maybe the width of your neighborhood or the width of your town. Or heck, I live in Colorado.
Exactly.
Colorado's only 300 miles across. My entire state is smaller than an atmospheric river is wide.
That's right. I mean, I was floored when she gave us those numbers. I was like, I had no idea that they were that large. Nor did I realize that people in science had been using this term for many, many years. I guess this is one that they just kind of got into the news and everyone was talking about. But it's so cool when you think about the science of how this happens and all this kind of stuff. So I hope all of you do this challenge. Share your results with us. We are at KidSolve at Facebook, Instagram, and Twitter. And again, don't forget to check out our website, solveitforkids.com. We will have more information about atmospheric rivers there and also some books that you can read to learn more about weather and the atmosphere.
Absolutely. Love weather. And I know in between now and more episodes, I don't know what Jen's going to be doing, but I am going to be looking up how far atmospheric rivers work their way into the American continent, because Colorado's not too much farther inland than California. So I need to find some stuff out. Until next time, you'll hear Jen and Jeff on Solve It for Kids.